Okay, guys, so today you're going to be working on a virtual lab, and I want to go through and show a few things that you're going to have to click in how this virtual lab will work. So, on your Google Classroom assignment, you have a link to this virtual lab, and it should be called Forces in Motion Basics. And the link will start with PEHT.Colorado, so FET.Colorado. So we will be doing all four parts of this particular virtual lab on different days, but today we're just working on the net force one. When you first open the link, this net force box should be highlighted. So you'll click that. And once you get here, what we're going to be doing is we're going to do some different tests and trials with a game of tug of war. And so on your screen, I need you to click sum of forces, values, and speed. And that way, as we're going through and filling out our digital worksheet for the virtual lab, it's going to ask you some questions that you will need to have those boxes checked to be able to answer. Okay, so let's look over at our virtual lab sheet. It says you and some friends are at the park. You find some rope and decide you'd like to play a game of tug of war. Unfortunately, there are 5 people, so you can't have an equal amount of people on each side. One of your friends suggests that the 2 biggest people should be on one side while the 3 smaller people should be on the other. Do you think this is a fair way to split up teams? Why or why not? So you're just going to answer that question solely on your opinion. Do you think that that scenario will be a fair way to split teams? We don't have to be nitpicky about it. Some of my classes in the past have argued and things when we've asked this question with each other. So just answer what you think. That's all I want to see is what you're thinking on that one. And then it says, what causes objects to move or stay still? This is the overall question for the virtual lab. You do not answer this question here. You're going to answer it later after we get some data. So let's look at how to set this up. I'm going to go through and show you how to do task 1. And then you can do task 2, 3, and 4 by yourselves and finish out the rest of this on your own. So on task 1, it says place 2 people that are the same size, the same distance away from the cart. So on our, and you can see this picture kind of shows you exactly what to do. You're going to go back to your virtual lab tab. And you don't have to do it exactly the same way it was on that picture. You can pick the big people and put them the same distance away if you want. Or you can do the little ones and put them on whichever dot. But wherever you place them, you have to make sure that you place one that is the same size as each other and put them on the same knot on the rope, because that's what the task said. Okay, so we did that. It says make a prediction about the movement of the cart. So when I look at this, I've got 2 people that are the same size, they're the same distance away. What do I think? Do I think blue's going to win, red's going to win? Do I think the cart's going to move to the left, to the right, or stay still? What do you think? So I'm going to say blue wins. Now, that's my prediction. And so you would do your own prediction. And then it says actual movement, none, left, right, whatever. So I'm going to come back over to my virtual lab after I've made my prediction and click go. And I'm going to wait and see what happens. So it's none. There's no movement here because we have equal forces that are pulling opposite directions. And so there was no movement. Okay, here I'm going to go back and look at what was the sum of forces. So sum of forces equals 0. And I'm just going to type that in. Now 0 what? What unit do we measure forces in? And that will be newtons. And so 0 newtons. Okay, and that's all you do. That was task 1. Task 2, you're going to do something different. And it tells you to do place people of whatever size. It says, let's see, It says place 2 people the same size, different distances away from the cart. So you're going to do the same exact thing, but just move people that are the same size and put one on one side at maybe knot number 2, one on the other knot. And I'm not going to do this for you, but I do want to show a couple different things. So if I have, now you can see that on my sum of forces, it says 100 newtons and it has an arrow pointed to the left. So I had some questions before on this part of the table where it says X left, X right. If I was doing that for this particular task, then it says 100 newtons and I'm going to say 100 newtons in whatever direction my arrow is pointing in. So that would be, for the way it's set up right now, it would be 100 newtons left is all that you do there. Whenever I click go on this one, there is going to be movement, and so the cart is moving over to the left. And each time you want to reset, you can click return and you can do the same thing over, or you can click return and move your people off and restart with your new people for your different tasks. So you have 3 other tasks. So task 2, task 3, task 4, where you do all of that exactly the same as what we just did. And then you're going to come down here and you're going to give me a claim, your evidence, and your reasoning. And I don't think we've done this in class yet. So claim, evidence, reasoning is a great way to write out scientific explanations and answers to scientific questions. So your claim is, what is your answer to the question? Today we're trying to answer what causes objects to move or stay still. So your claim today is, what is your answer about what causes objects to move or stay still? You want to answer that in a complete sentence or sentences. Then you're going to come down here and you're giving me your evidence. What specifically happened? What numbers from these tasks? So on this one, it stayed still. What numbers do you see? On some that may have moved, what numbers do you see, specific numbers that support your claim? So you might say, well, when the cart stayed still, I saw that there was this blank force. Or when the cart moved, I saw such and such. That's your evidence. Your reasoning, today I'm walking you through reasoning because we haven't done this yet, but your reasoning is, what about that evidence or those numbers connects back to your claim. So I saw this evidence, and I know that my reasoning would be, I know that these numbers match up to my claim because, well, this is our first time doing this and it's a little bit complicated, so I'm walking you through it. And so if you answer these questions, these bullet questions, then that's going to end up giving you a good reasoning set of answers to match up to your reasoning. And so all you're going to do is answer these questions based on what you learned in the virtual lab. So then you have 2 other questions. This one says, now that you have had a chance to experiment with this simulation, go back to the question at the beginning. What do you think would be the best way to divide up your friends for the game of tug of war? The very, very first thing that we looked at, the 5 friends playing tug of war. Based on what we learned in the simulation, what do you think would be the best way to divide them up fairly? And be sure to explain your reasoning. Complete sentences, more than one sentence. And then the very last thing you're going to do is come up with your own experiment, and it will help you to answer the question of how to divide up the friends and explain what you learned. So normally, if you were doing this on paper and pencil, I would have you actually draw out what you did with your stick people. We're not going to be able to draw that. So I'm going to need, if you do a big person, I'm going to need you to be specific and explain exactly what you did on your own experiment. So I did one big person on the last knot, and a little person on the 3rd knot, a medium person on the 4th knot. Just be specific about what exactly that you put on your experiment. And then you're just going to run it through. I want you to tell me in your explanation basically what all we put in these boxes. And so you tell me, describe what setup you used, what did you see, what were the sum of forces, and then explain what you learned from that.